So where we've been, we've already talked about it. We've done hypothesis testing. That's where you kind of got tested over it a bit just a few minutes ago. And then this is really what we're going to continue with for the next 1, 2, 3, 4, 5 weeks. I added some more weeks. So we've got independent t-tests this week. We've got dependent t-tests and proportional tests next week. We've got ANOVAs the next week. We've got 2 weeks for the ANOVA. I guess actually that's when it stops. So we've got 4 weeks. So our steps for hypothesis testing. You all typed those in very well in your last quiz. We're going to follow those today. Where we've been. I mentioned that we didn't really do the test to see if we have a normal distribution. We're going to do that today. What we have done is, if we had one sample mean and we were comparing it to a population mean, or if we had one proportion, we compare it to a population proportion. So when we have sample means, we were always setting up null hypotheses using the mu symbol. Proportions, the peak. Should look familiar with one of your test questions. And then we've learned how to do some stuff in stats. So we're just going to kind of continue this. And today what we're going to talk about, so we're still in hypothesis testing, but now instead of comparing one sample to a population, so a given value, now we're going to compare one sample to another sample. And today, these 2 samples are going to be independent of one another. Right? So independent, somebody tell me what independent means to you.
One doesn't influence the other.
They don't influence each other, right? And that's really the big thing. They're independent, they're not dependent. Right? So one doesn't influence the other. You can take them from one population or 2 populations. You're going to randomly select them, but there's no interconnection between any of the samples. Okay. This is called a 2-sample t-test or an independent t-test. The null hypothesis for this can be written in 2 different ways. I only put one on the screen. I prefer one mean equals the other mean. You could also do a little math and say that the null hypothesis is the mean of the first group minus the mean of the second group is equal to 0. So the difference between the means is 0. So you can write the null hypothesis in either one of those ways. Obviously, you can have less than or equal to and greater than or equal to as well. So you can have the full gamut of symbols in between. One thing we do want to kind of consider is that whenever we're writing this, we have to know what group 1 and group 2 are. Right? So here, they're just generic, group 1 and group 2. Right? If I'm talking about drug A and drug B, then I use my subscripts to say A and B. Right? If I'm talking about freshmen versus sophomores, right, you can either write a note that group 1 equals freshmen and group 2 equals sophomores, or you can say the mean of the fresh equals the mean of the soph. Okay. But being very clear in what your hypotheses are is very important, right? Especially if you start having things that are directional, right? Are you trying to test that the freshmen are better than the sophomores, or the sophomores are better than the freshmen? Okay. Hypothesis test. So there's our null and alternative. How we're going to do it? It's the same way I kind of taught you how to do the 1-sample t-test, except now we're going to do a 2-sample t-test. So we're going to analyze, we're going to go to ANOVA, the t-test, and 2-sample. And then we'll click around and see all the different features we have on the map. So when we're comparing 2 means, we're going to start with the independent t-test. So our 2 groups are completely independent of one another. So an example that we have is marketing advertisements impact on customer perception of a product. Right? So we're looking at the average satisfaction score. So one group is going to see our old ad, one group is going to see our new ad, and we want to see if the average satisfaction score changes. Okay. In this case, we want the average satisfaction score of our new group to be higher than the old group. Or why else would I make a new ad? Agreed? Okay. So are you comfortable with the nullity alternative hypothesis here? Okay. So the only difference from before is instead of having an actual value, now I just have one sample versus another.
Instead of having like a population value.
Right, yeah.
Right, okay.
Yeah. So I could have, so if I had an established old satisfaction score, then I could write this as the mean of the new is greater than that old score. So that old score was a 6.
Okay.
Okay. So if I knew what my population score was, I could do that.
Right.
But I don't know. So here I'm going to say, I haven't gathered this particular satisfaction score, so I'm just going to say, here, you guys watch Group A, you're going to watch my old ad. Group B, you're going to watch my new ad, and we're going to see if there's a difference in their satisfaction score. You guys okay with this? Do you have any questions? Better question. What questions do you have? Okay, so that's comparing two means. I already had this, but here's just kind of the picture. So we're going to go to Analyze ANOVA, we're going to go to t-test, and we're taking our two samples. We're going to be able to have the analysis variable. So this is going to be, the analysis variable is the same thing as what you would consider a dependent variable. Okay, so analysis variable in this case is going to be our dependent variable. Our classification variable is going to be what you have previously heard is called an independent variable. Those words seem familiar? Okay, so our analysis variable is going to be our dependent variable. That's the thing that we're actually going to be measuring. Our classification variable is going to be our independent variable. That's our grouping variable. Okay, so I'm going to be looking at, is there a difference in net sales between types of customers? So one of the things you're going to have to consider, I'm not going to get too much into it today, but we will in a little bit, data setup. So for SAS to be able to do, for SAS EG to be able to run an independent t-test, your data has to be in the form where you can choose an analysis, a dependent variable, and an independent variable. So you have to have an independent variable in one column and a dependent variable in the other column. So you have to have one column that says type of customer, in this case, and another column that has net sales in it. Why I point that out? Okay. In some of the data sets that you may have for like an assignment, it is possible that what you would have would be, let's say our type of customer, we have our promotional customer and our regular customer. And then the values that we have here, so these would be two columns, and then you would have net sales in these two columns. SAS can't handle that. Okay? So if you have data that's set up in this situation, SAS is not going to be able to have an analysis variable and a classification variable. Just fun FYI. Store that in the back of your mind for later when you do your homework. Okay. The way we set up our data is going to be important. So let's just do something. I find that doing something is more fun than listening to me lecture about it. So if you want to follow along, you're welcome to. If you want to watch, that's cool too. So I'm going to go play in my dirty data set. If you want to follow along, you play in your dirty data set. textbook doesn't get into this in very much detail, but there are really, let's see how I'm going to put this. I'm going to go back and do a little editing on my slides. I'll repost them for you guys. There's a couple of assumptions that we make when we're doing our independent t-tests. One of the assumptions that we make is that our dependent variable is normally distributed. And another assumption that we make is that the variances for the two groups are equal. Obviously, one of the other assumptions we should make would be that the two groups are independent. There's a few extra assumptions that we're making. So we're actually going to test these assumptions. So ultimately, my business question is, just are my net sales significantly different between my regular and my promotional customers? So that's my big question. So if I come over, the first thing I'm going to do is I'm actually going to test the assumption that my dependent variable is normally distributed. And the way that I'm going to do that is I'm going to scroll down here to the bottom.
What
Yes.
data set are you using?
My Razorback Dirty data set.
Oh, okay.
And if you're pulling in just the Razor, or if you're pulling in just the data set, it's the Thursday data set. Either one, I mean, it's going to work no matter what you do. So for any data set that you have, so here's my data set. We know this happens, and I forgot to run my process flow, so I'm going to go back and run the project, or either run the project or run the process flow. So our question is, are net sales significantly different between regular and promotional customers? So while that's running, let's set up our null and our alternative hypothesis. So what two groups are we going to test? Regular and promotional. And we're looking at, so really we need to kind of edit this question a little bit. So we have our net sales significantly different. What metric are we going to use? Are we using the proportion of net sales? Do we want to use the average of net sales? You want to do average? Okay. So let's say, are the average net sales significantly different between the regular and promotional customers? So now, we've got, again, that's me trying to write the population mean. So the mean of the regular customers and the mean of the promotional customers. So what symbol should go in between there for my alternative hypothesis?
Not equal.
Not equal to. Why would I pick not equal to? That's my keyword there. I'm just looking for differences. I don't know if one's greater, I don't know if one's less. Now, do I have a hypothesis that, or do I have an idea which one I want to be more?
Probably promotion.
I mean, it makes sense that if I'm doing promotional, I want the average sales for my promotional to be happy, right? So I could have written this question. So here, first let's do this. Here's my null, and here's my alternative. I could have written this question, are the average net sales significantly greater or here. So greater for promotional, than the regular. So then, what would my symbol be between my regular and my promotional? So less than,
Yes.
right? Because of the way that I wrote it, it's the mean of the regular is less than the mean of the promotional. So then I would have the regular greater than or equal to promotional. Could I have written this the other way? If I would have put promotional first, then I do greater. So it doesn't matter how I write my null and my alternative hypothesis. What does matter is that I label things correctly, right? So I'm going to pick a usage in front of me, right? So Rachel could write this one, and Kelsey could write this one, and they could both be correct. But if instead of regular and promotional, I had 1s and 2s, and nobody told me what 1 was, and nobody told me what 2 was, right? So if I was to write the mean of 1 is less than the mean of 2, is the question right? Is it wrong? How do I know? Just making a point. There may be a good reason that I'm making the point. I may have graded the Saturday classes quizzes while you guys were taking your tests, and maybe this was something important. Making a point. Okay. But we want to be clear. If we're writing our null and alternative hypothesis, we want to be clear about which mean we're talking about. All right, so let's go back. So I'm going to stick with the green. Okay, so we're just looking at the difference between the two. I don't know which one's better or worse, just that there's a difference. So by now, all of my stuff is ran. I'm going to go to my query. And so I'm going to make a two-sample t-test. So I'm going to analyze. Oh wait, sorry, we're going to look at the normality thing first. So looking at normality, is the dependent variable normal or not? So we're going to describe. We're going to go to a distribution analysis. So we're looking at, is our variable, is it going to be normally distributed or not? So then we're going to choose our variables. I'm interested in net sales. And you'll notice this has to be a continuous variable. Okay, so I'm interested in net sales. And then I'm going to do the distribution. I'm going to click on summary. I'm going to look, so this is going to give me a picture of, does it look normal? And then I'm going to go down to tables. I'm going to click test for normality. You can uncheck these boxes if you want to. So you only get the information that we want. You can leave them checked, whichever you want to. So I'm going to go back real quickly. Make one slight edit to your slides again. Because right here, the one thing I left off was you're also going to go to tables and do the test for normality. And then those are actually the analysis we're going to look at. So I'm going to hit run. Let's see what we come up with. So this right here these three tables are what we've already gotten before. Alright, so those are those first three boxes that you can check or I told you could uncheck. So this is the new piece right here. Our test for normality. And when we're testing for normality, our null hypothesis is going to be that it's normally distributed. And so that our dependent variable is normally distributed. Our alternative is that our dependent variable is not normally distributed. So if we have a p-value and we have an alpha level, I'm just going to go with our standard alpha level of 0.05. I'm going to focus on the Shapiro-Wilks test, just because that's one of the more popular. I always like to try to say the Kolmogorov-Smirnov, just because I think it's fun to say. But the Shapiro-Wilks is probably one of the normality tests that I use the most. So what we're looking at here is a p-value that is less than 0.0001. That's less than our alpha level, so what is our statistical conclusion?
Don't reject them.
Because what's the alpha we do reject it?
So our p-value is less than our alpha level, so we are going to reject our null hypothesis. So that means we're not doing this, we're doing this. So is our dependent variable normally distributed? Okay, so according to this, net sales is actually not normally distributed. But that was one of our assumptions. This is the part that I hate about stat classes. How many times have you been in a stat class? And they say, it's okay, don't worry about it. Right, so we always tell you to go check this normality assumption. But then when it violates this normality assumption, we're just like, really, it's robust against normality, don't worry about it. I kid you not, I've been in a lot of intro stat classes, and every time I've heard that and I've said that. And it is true. So one of the things about this, the t-test, is that it is fairly robust against variations from a normal distribution. There are some corrections that we can make, and we'll look at those. For right now, the other thing we could do is we could actually scroll down a little farther. Actually, I didn't. But if we went and we looked at our data, right? So here, technically, using these test statistics, we say our net sales are not normally distributed. And really quickly, did you guys like that I did the snipping thing? Was that okay?
It's very clutch at the moment.
Did that seem to help a little bit today?
They've just made it.
Oh, where's it at? Last time it stayed. There we go. Okay. So we'll pause for a moment. So we could also, if we would modify the task, one of the things that I thought it was going to give us that it didn't, is we could have asked for like a histogram plot. So we could actually see what our data look like. Sorry. The bad part about erasing on here. So here, while I'm erasing, you guys look. And what do you see? If you had to say, is this normally distributed, what would you say?
No.
I mean,
Almost.
what's the one thing that you're like, ah, crap?
That.
That thing, that really tall thing that's sticking out in the middle. So we had a lot of people that were buying $150 worth of stuff. But other than that, I mean, it is fairly normally distributed. So even though we have violated it based on our test, we still feel fairly confident that we're going to get good results. Okay. If you do violate an assumption, then really that what we're kind of looking at is like, we have to be a little more wary of the results that we're going to come up with, but we can still be good. So, normality. The next thing we're going to do, do you guys have any questions about this? Yes.
How did you get the LOA? I was following along, but I'm just getting the graph without the LOA.
You're getting the graph without the yellow line?
Yeah.
It's plots, and I did a histogram plot, and it just gave it to me. I got nothing on that one. I didn't click anything extra. It was just plots, and I did a histogram plot, and it just showed up. If it doesn't show up for you, we'll play with it and see if I have extra settings. But that's all I did. So it's normally distributed, it's not normally distributed. Going back to our big business question, let's actually see if there's a difference between our two groups.
Okay, I figured that in the distributions in summary, normal has to be T.
Oh, okay. Which would make sense because then, there you go. So if you would have picked one of the different distributions, it would have overlaid it with a different distribution. All right, so we're back to our data set. I want to compare, is there a difference between my regular and my promotional customers? So I'm going to analyze ANOVA, and I'm going to do a t-test. While I'm doing this t-test, I want to do a 2-sample, and this is going to be our independent t-test. The data that I'm going to use, so my analysis variable, my dependent variable, is going to be my new net sales. And my classification variable is going to be type of customer. Ooh. The variable assigned to the classification variable must have 2 and only 2 distinct values. So if you'll remember from my original data, type of customer had like a typo in it. So I can't use type of customer, I've got to use my new type of customer. Okay, so since we're doing a t-test, we can only have 2 groups. So your classification variable can only have 2 groups. Yes?
What are the differences between new net sales and new underscore?
Yeah, so the difference is, so new underscore net sales has a bunch of decimal places, and new underscore net sales, so it doesn't matter which one you use. As long as you're using a new net sales, you're good to go. I know, not the best naming conventions. Learn from my mistakes. All right, so we have this, so we have our data that we're going to do. So then comes the analysis. So here, we have a null hypothesis. What do we expect the difference to be between these 2 groups? 0, right? So if there's no difference between the 2 groups, then the difference would be 0. Okay, so we're just going to leave that at 0. There could be some instance when you expect the difference between the 2 groups to be some value, and you can change this, but 99% of the time, when you're doing a 2-tailed test, you're going to leave this at 0. The plots, you can put in whatever we want. We can have all sorts of fun with all the plots. We'll see what they are. We'll leave the titles as defaults, and the properties are just what's going to happen. So we're going to run, and we're going to see what all we get out of an independent t-test. So we have a bunch of information, we've got a bunch of graphs, all sorts of fun stuff. So I'm just going to kind of go through the output and talk to you about what it is and how we're going to use it. Okay? So remember, our question that we're looking at is just, are there significant differences between regular and promotional? So we're doing a 2-tailed test. Okay. So if I go back to this, my null hypothesis is that regular is the same as promotional. My alternative is that regular is different than promotional. The alpha level we're going to use for all of our things is 0.05. So the next thing we need would be a test statistic. That's step 3. But if you look down, so that let's start at the beginning. So this first step right here, this is going to be your descriptive statistics. So you'll notice that a lot of the output that we do, instead of making you go to the summary statistics and get information, it just kind of gives you some summary statistics right along with it, which is kind of nice. Our second block down, again, is kind of some more descriptive statistics. So now we have some confidence intervals. Or I guess really we just call them confidence intervals. So here's our confidence intervals. And then our third block down is our independent t-test. So here's our independent t-test results. But there's a fourth block. Now on the top of it, it says equality of variances. So what was one of the assumptions that we had for an independent t-test?
Variances are equal.
That the variances were equal. So even though we're doing an independent t-test, we're going to take a side step. So we already took a side step to see, is our dependent variable normally distributed? Now we're going to take a second side step, and we're going to ask the question, so new null hypothesis, is the variance for group 1 the same as the variance for group 2? Our alternative is the variance different than? So we're going to test the equality of variances. Are the variances equal or not? So here, would we want to reject or would we want to fail to reject our null hypothesis? What's our happy place? Right. Our assumption is that they're equal. So I'm happy if they're equal. So I'm happy if I fail to reject my null hypothesis. Well, so let's check. So, step 3. So there's my step 1. My step 2 says, give me an alpha level. My step 3 says, give me a test statistic. And here our test statistic is 11.08. That really doesn't matter, but I'm getting it from right here. The part we're really interested in is our p-value. And our p-value is going to be less than 0.001. Okay. So step 5, if my p-value is less than 0.001 and my alpha level is 0.05, what's my statistical conclusion? I'm going to reject my null hypothesis, which means I'm going to reject that and I'm going to conclude, are the variances equal? So I'm going to conclude that the variances are not equal. So what does that mean? So it means that when we go back to our independent t-test, you'll see that there's 2 lines. One says the variances are equal, and one says the variances are unequal. This is our quality of variances. So since we have that the variances are not equal, the variances are unequal, that's going to tell us to use the bottom information for our answer to make our conclusions. Okay, so you notice the p-values are a little bit different, the degrees of freedom are a little bit different. So when our variances are unequal, we have some correction factors that we do. Your book gets into the math a little bit. We're not going to worry about the math of it. We're just going to say thanks, SAS. Unless you want to get into the math. Okay, so now we have our null hypothesis for our t-test. We have our alpha level. Now we have our t-statistic, our test statistic that we're going to use, which is the bottom row, which is 0.79. We have our p-value, which in this case is 0.4320. So the one-tailed test or a two-tailed test? Two-tailed. So do I need to do anything special with my p-value? P-value's happy. So step 5, my p-value's big, my alpha level's small. What's my conclusion going to be? Fail to reject. I accept, I retain my null hypothesis. So I keep that one. So what is my conclusion?
There's no significant difference between negative promotional.
There's not a significant difference. So one of the things we could have done before we even started was to actually look more closely at our two groups. So our promotional customers spend about $159, our regular customers spend about $157. So are you surprised with this result? Right. Did you expect them to be different? Right. Did you expect a $2 difference to be statistically significant? So our conclusion is there's, and you can say this a lot of different ways. There's not enough evidence to support that they're different. You can say, in fact, that's probably what I'm going to write. So there's not evidence to support the two groups being different. You could say let's put it in context, the average net sales for regular customers is not statistically different. Promotional customers. I'm going to give a shout out to one of you. I graded assignment 4 last night. It was great. It was wonderful. I had so much fun. You guys did really well on it, by the way, for the most part. Out of the 30 of you, one took this answer a step further. And so instead of just interpreting and telling us the business conclusion is either there's not enough evidence or saying the average net sales for regular customers is not statistically different, took it that one step further and actually went back and looked at the descriptive statistics and said something to the account. Like, so this one is like, there's only a $2 difference between the groups. Okay. So for the other assignment, for assignment 4, it was, we were actually rejecting the null hypothesis, and we were saying that, I'm trying to remember the question. I graded so many, I'm trying to remember the question. The textbook, I'm going to go with the textbook question, because I remember that one. It was the last one. And most of you did it. So there was a $90,000 difference between the population and the Ohio State administrators. Okay. So it was like, yes, reject the null hypothesis. There is a difference between these two things. And again, that person took that one next step and said, in fact, there is this much of a difference. Right? So not just saying that there is a difference, but taking it back to the descriptive statistics. Okay? So when you really want to start making, and the reason I'm kind of pointing this out is like, so for assignment 5, it's going to be coming up. Right? You have your statistical conclusion. You have your business conclusion that puts your statistical conclusion into words, but then go ahead and make it meaningful, right? So there is a difference, or there isn't a difference, but go back to your descriptives and look at it and actually kind of put it into context. Okay? So, whoever did that, you know who you are. Total props. And if you didn't, and you don't remember, then hey, somebody did a really great job, and yay. So you can take that one step further, next step, and say, there's only a $2 difference.
So would it be fair to say that the $2 difference isn't a significant difference?
Yes.
Okay.
Yes. So there is a difference. So, and that goes back to like when we're just looking at point estimates, for promotional customers, on average, do better than regular customers. We can look at a confidence interval, see what happens. Now we're going to say, yes, they are different, but they're not statistically significant.
Okay.
Questions, comments, thoughts about this craziness?
The same thing, if you describe it based on confidence interval, then you'll see that the difference is actually very significant. This is a 95% confidence interval.
Yes.
In the mean as such is not so different, but when you see the confidence interval of 95%, you see that.
Right, because they're overlapping, so they're not different. Is that what you're telling me? Let me copy and paste this real quick and we'll go back to it. So yeah, so if you use your confidence interval, around a space, we're going to go down here for the confidence interval. So for the confidence interval, you have your promotional customers that are going from, let's do it this way, regular. So the promotional go from 154 to 163. The regular customers go from 155 to 159. And since confidence intervals overlap, there's no difference between them.
I looked at standard deviation instead of mean, that's fine.
Ah, you're looking at the standard deviation part. Okay. So yes, so the standard deviations, if you're looking at the confidence intervals, they are different, which corroborates what we have over on the right, that our variances are different. Absolutely. Questions, comments, thoughts? What would change if we made this directional instead of non-directional?
The p-value.
Alright, so things that would change, right? So we think promotional's better than regular. So we do that. The alpha level stays the same. The t stays the same. The p-value gets cut in half. I have to do that in my head. 2, 1, 6. There you go. In this case, we still fail to reject, everything still happens. Does anything change over on the right when we're looking at the equality of variances? Does anyone want to? Yeah, so does anything change over on the right with the equality of variances? No, all that stays the same, right? So the equality of variances stays the same. We're still looking at, are the variances equal? The only thing that changes is that p-value. Questions about that? Yeah.
If you were to go back to modified task, if you're doing a one-tailed test, is it the value in the null hypothesis false? Is it a 0?
No. Because even though it's a one-cell test, we're still saying that the difference between the two are 0.
Okay.
Right, so if these two groups were the same, right, so if the mean for the promotional was $160 and the mean for the regular was $160, then is there a difference between the two? No. So 160 minus 160 is 0. So if these two things are the same, I would expect the difference to be 0. So even if you're looking at it from a one-tail perspective, that still holds.
Okay.
Yes.
I don't really agree on that because it doesn't say equal. The null hypothesis is greater than or equal to. So it need not be 0. It could actually be the regular is very high compared to promotional. You would still accept the null hypothesis.
Yes, which is why I don't like writing it like this. Yes, exactly. Which is why I don't like writing it like this. But staying consistent with your book, this is what it is. So basically what we're doing is we're either going to reject or, okay, so it's all about the null hypothesis, right? So if we write the null hypothesis as it's greater than or equal to, and we reject that, then we can conclude that the regular is less than the promotional. So that can happen. When we fail to reject, then that null hypothesis becomes a little bit more important, and you have to go back and really look at what you can conclude is that it's equal, or in this case, it could be greater than. But that still doesn't change how you would run the SAS output. Any other questions about this? Yeah.
Wait, just to clarify what you said. So if you were to write it how you like to write it,
Yes.
it's less than or equal to 0. But the option on SAS is just equal to, you still just put 0.
Right, so it's always, yeah, so right here, the way this looks is that it's written as greater than or equal to. But if you went here, it'd be hard to see it for a second, so I gotta step over it. This is always going to be the null hypothesis equals 0. And so the way that the calculations work, the calculations can care less about how you set up your null hypothesis. They're going to calculate the test statistic the same way no matter what the null hypothesis looks like. For us, the null hypothesis is more about our interpretation piece. Other questions?
So the way I see this is, once we do the test, you first look at the descriptive statistics. If you find that regular is higher than promotional, then you just don't even look at the rest of the statistics. You just say that the null hypothesis is accepted. If regular is more than promotional, then you just say that null hypothesis is accepted. Don't even look at the test.
So
if promotional is higher, you look at the test.
the idea is that you're setting up your null and alternative hypothesis before you see the descriptive statistics. So if you set it up beforehand, then that doesn't actually work, right? Because if it's already set up, then the idea is that you run your analysis. But, I'm with you. If you have looked at the descriptive statistics before you're actually writing your null hypothesis, then make sure that you write your null hypothesis correctly. I mean, that's your first step, right? Is to make sure that if we know the regular is bigger than the promotional, then we want to make sure that we write our assumptions and our hypotheses correctly, so that we're actually testing what we want to test. Right? Because if not, then you're going to wind up in this sticky, well, I failed to reject my null hypothesis, even though regular makes, the regular customers are spending $180, my promotional, we're only spending $150. My hypothesis wasn't good. Right? So you do have to be careful. And it's not just a blind thing. That common sense definitely plays a part. Absolutely.
So the business question is that, then it obviates the need for hypothesis testing. You look at the descriptive statistics and you answer. You don't even do the hypothesis.
No. Because of this exact thing right here, right? So if you just looked at 159 compared to 157 as point estimates, then yes, you can say that promotional customers do more than regular customers. But is that a statistically significant amount? Right? Is that something that I should actually consider as meaningful, or is it not? So that's the purpose of the statistical test, is to actually take it that step farther and support what you're seeing in your descriptive statistics. Right? So this is kind of what we're doing like in your projects, right? So what we're going to spend the last 20 minutes of class on, your project, you're doing your descriptive statistics. You're learning about your data to help you formulate business questions. Right? Once you have all this descriptive statistics, then you should be able to create hypotheses that are going to help further what you've learned in your descriptive statistics. That help? Do you have any other questions about what we're seeing here. If you don't have questions, I think this was about all that I really had planned for today, was just to kind of introduce independent t-tests. Okay? So, learning chapter 9 and learning all the nitty gritty, the type 1 errors, how to set up a hypothesis, all of that stuff, now the only thing that's really changed is step 3. So now instead of doing a 1 sample test, now we're doing a 2 sample test. All the other stuff's going to be the same.